Nomenclature in a nutshell. So basically, how do you write the name of a chemical you have a formula for? We've done the other way around where we had the name and we're going to go get the formula, but now we're going to go the other way. So first thing you really have to pay attention to is Roman numerals and transition metals. That's where complication really begins. That's where the challenge in the section is. If I were to tell you iron 2 chloride, all you would have to do is just write Fe positive 2 because Roman numeral tells you chloride negative 1. You crisscross, you get FeCl2. Pretty simple. But what if I give you the formula and ask you for the name? Now it's a little bit more complicated. So for example, let's say if I give you FeO. So in this situation, you have to actually figure out what the Roman numeral is for Fe. But remember, reduction is in place. Remember the rule for crisscrossing? Once you write a formula, if you reduce it, you do so. So how do you realize that's what happened? So the way you figure that out is you crisscross the numbers. So in this situation, if I crisscross it, both these are 1, right? So O would be a negative 1. Fe would be a positive 1. The way I would realize that this thing has been somehow reduced is the fact that the anion doesn't have the correct charge. So that's the game you have to play with this. You have to make sure the anions have a correct charge. That's what you need the periodic table and your polyatomic ions for. So we know O is not negative 1. We know it's a negative 2. So we have to do in this situation, multiply both by whatever number gives the correct charge on the anion. And I did a really poor job of doing this. So let me just try it one more time. So 2, O, negative 1, 2. So when we do this, we get Fe positive 2, O, negative 2, which is what we want. So O has the correct charge. So why is this important? Because when I'm naming this, I can't just say it's iron oxide. Anything that's not in group 1A, 2A, 3A, and ZAC, which are right here, these have Roman numerals. The only exceptions are those. So if it's 1A, 2A, 3A, or ZAC, you don't need Roman numerals. You need to do all this stuff for it. If it's any other metal, you have to go through all this. And that's where the challenge comes in. So when I'm naming this, this would be iron, Roman numeral 2, because we have to have Roman numeral, oxide. And that's really where the challenge of this comes in, is dealing with the ones that have Roman numerals. The other ones are really easy. If it's 1A, 2A, 3A, or ZAC, just name it, call it a day, you're done, nothing to do. But if it's not one of those exceptions, you have to sit here and do what I just did with the iron and figure it out. And that's where the challenge comes in. So you must first determine where the metal is from. That's the reason. Compounds involving metals that don't need Roman numerals. So here's your exceptions. The metals are from group 1A, 2A, 3A, or zinc, silver, and cadmium do not use Roman numerals. So all you have to do is name these and you're done. NaCl, group 1A, sodium chloride. I don't need to uncrisscross or anything cute. You're done. So if it's any of these, there is no uncrisscrossing. That makes your life a little bit easier. Magnesium chloride, group 2A. Just name it and call it a day. Aluminum, group 3A. Name it and call it a day. Zinc, it's one of the exceptions. ZAC, name it, call it a day. If any other metal, use Roman numerals to indicate its charge. For example, Fe2+, Sn4+. You actually have to figure it out the way I did with the iron. So FeCl3, how did I know that iron was a positive 3 charge? I crisscrossed it. So if it's not from those exceptions, you have to actually sit there and do this. Make sure the anion has the correct charge. It does. Chloride is a negative 1 charge. So it's iron 3 chloride. You have to do this every single time. It's not one of those groups. You have to crisscross, verify the anion is correct, and you're good to go. Iron 2 chloride, so on and so forth. When you don't have a metal from group 1A, 2A, or 13, remember 1, 2, and 13 correspond to 1A, 2A, and 3A, uncrisscross the subscripts and make sure the charge of the anion is correct. So FeCl3, and crisscross it, verify chloride's good, we're done. Iron 3 chloride. When there are no subscripts, CuO. Now the shortcut for this is just whatever the charge of the anion is, it's going to be the charge of the cation. So you don't need to uncrisscross and multiply by 2 if you don't want to. If there's no subscripts, your life's a lot easier. O is a negative 2, so guess what copper has to be to get a charge of 0? That's right, positive 2. So it's just copper 2 oxide. Done. Don't need to sit there and analyze. Makes it a little bit easier. SNS2, they're subscripts, so that's what you got to do, because it's not 1A, 2A, 3A, or ZAC. You have to crisscross it, and then you look at it and say, wait a second, that does not have a negative 1 charge. What's wrong with this picture? So you have to multiply both by 2, and then you get SN4 plus, S2 minus, that's tin-4 sulfide. That's the extra step you have to do. That's about as complicated as you can get nomenclature. You have to crisscross and figure out the Roman numerals, but there's no way around it. FeCl2 is just going to be iron. Check. So uncrisscross, Fe positive 2, Cl minus 1, chloride is a negative 1, so iron 2, chloride. SnO2, not group 1A, 2, 3, or Zach, so uncrisscross, you get Sn positive 2, O negative 1, that's a prom, multiplied by 2, multiplied by 2, tin-4 oxide. So there is a little bit of thinking involved, but it's not impossible. As long as you know what you're looking for and you're consistent about your approach, this is doable. So FeI2 on crisscross, Fe is a positive 2, I is a negative 1. This becomes iron 2 iodide, and that's because I is indeed negative 1. Beryllium oxide, there's no subscript, so all I need to do is figure out the charge on the anion. That's going to be the same as the cation. If this is a transition metal, it's not. It's group 2A. It's called beryllium oxide. Have a nice day. There's nothing to do here. So that makes it a lot easier when there is 1A, 2A, 3A. Here, it's not from one of those exceptions, so I have to actually sit there and crisscross, uncrisscross, 4 plus I minus. I is correct, so this is going to be tin-4 iodide. On crisscross, Mn4 plus, N3 minus. Nitrite is indeed negative 3, so checks out. So just be manganese 4, because positive 4, nitrite. And the last one, no subscripts, so the charge of the cation is going to be the same as the anion, so it's going to be copper 1 iodide. That's nice when there's no subscripts. If the compounds contain 3 elements, use the following. Identify the polyatomic ion. Name the polyatomic ion it's attached to. So in this situation, polyatomic ion is ammonium. How do you know there's 3 or more elements? 3 capital letters. Really simple. 1, 2, 3 capital letters. Polyatomic ion. This is barium nitrate. Sodium phosphate. The same rules apply as far as the need for Roman numerals. These do not require Roman numerals. This one does. So you have to actually uncrisscross it. So when you uncrisscross, you get Fe with a positive 3, SO4 negative 2. SO4 does indeed have a negative 2, so iron 3 sulfate. You don't have to do anything else. The same rules as before to determine the name of the cation. All right, aluminum nitrate. Aluminum is a positive 3. Nitrate's a negative 3. Excuse me, negative 1. Crisscross, Al, because it's 2 or greater, excuse me, put parentheses around the polyatomic ion. And put a 3 on the outside, and you're done. Copper 2 nitrate, Cu, positive 2, nitrate, negative 1. 2 or greater, so we have to put parentheses, and you're done. Iron 3 hydroxide, Fe 3 plus, OH negative 1, 2 or greater. Crisscross means you parentheses. There you have it. Mistakes to avoid: never ever touch the bomb number on the polyatomic ions. They're not used to determine the formula. You can't change it. I can't change NO3 to NO2 because it's a different chemical. You just keep the bottom number as is, and then you can put these around it when you need to manipulate the quantity. So FeSO4 turns into Fe2SO4 Notice I put the parentheses around the SO4 instead of doing 4 times 3 to give me 12. Don't do anything cute. Just drag and drop, and you're done. Name the following compounds: calcium phosphate. So pretty easy. It's group 2A, so not much thinking involved. PO4 is a polyatomic ion. Once you memorize those, this will be really easy to recognize. FeBr3, this is not group 1A, 2A, or 3A, so I do need to crisscross. Br does have a -1, so just iron 3 bromide. Let's try a couple more. All right, aluminum sulfide, group 3A, so I don't need to worry about them crisscrossing. I just write what I see. Makes it a lot easier. Manganese is not group 1A, 2A, 3A, or ZAC, so I've done crisscross. Mn is a +2, NO2 -1, checks out. So manganese, 2, nitrite would be your answer. For this one, it's a polyatomic ion. There's actually 1, 2, 3, 4 capital letters, so it's definitely a polyatomic ion. But group 1A, so you don't need to sit there and do crisscrossing, just call what you see. Sodium bicarbonate or hydrogen carbonate, either one's fine. How you take care of doing nomenclature for ionic compounds.